Welcome to Virtual Math Masters. I'm your boy, Master Cruz, so you never do math alone again. And today we're going to learn how to solve inequalities. These are the basics, so here we go. To solve inequalities, you're actually going to solve inequalities very similar to equations. So you imagine this is an equal sign, and you're going to solve it the same way. It's just that it's an inequality symbol. So here we go. X plus 8 is less than 13, and we're going to solve for the variable x, right? So the whole goal is to get x by itself, but x is not by itself on that side of the inequality symbol. If you would like to draw a line so that you can see which side you're talking about, you can, but it's not by itself on that side of the inequality symbol on the left, because it's adding 8. So the inverse operation is subtract 8 from both sides. And when you're doing one side, right, oops, you gotta do it on the other. So when I do that, 8 minus 8 goes to 0. X comes by itself, it comes down. You rewrite the inequality symbol just like if it was an equal sign, you rewrite it, and you simplify 13 minus 8, 5. So I have that x is less than 5. So I could complete this here and say this is less than 5. And then the cool thing about this is that we can actually graph this in a number line, because now we want to show that 4 is not the only solution. There's many solutions, and all the numbers that are less than 5 satisfy this. So I always draw a number line, and I plug a 0 in the middle, and then I draw one more tick mark, and I plug whatever number I got as my result. So this is 5. This is just less than, so the 5 is not included. So I'm going to have an open circle. And where are the numbers that are less than 5? Well, x is less than 5 on the left-hand side of the 5. So I'm going to move to the left in my number line. Now, if you're not sure why this is closed or opened, please watch my previous video on solving inequalities intro, and I give way more details on how to identify which one it's less than, which one it's greater than, and all that great stuff. This is not closed, this is open because this is just less than. So that's it. All the numbers to the left that are covered by this arrow are numbers that make this statement true. X is less than 5. So if I plug in 5 over here, for example, 5 plus 8 is 13, and 13 is not less than 13. It equals 13, so that's not true. However, if I plug in the number 4, in the original problem, 4 plus 8 is 12, and 12 is less than 13. So this is telling me that any number that it's less than 5, so 4, 3, 2, 1, 0, and any negative number will always make this positive. Just as a reminder, this is the left-hand side, this is the right-hand side. Smaller numbers are always to the left, that's where the negatives are. Bigger numbers are always to the right, that's where the big numbers are, 100, 1,000, a million, etc., etc. So here we go. Let's do example 2. Example 2 says that negative 10 is greater than or equal to x minus 4. So again, I ask myself, why is the x not by itself on this side of the inequality symbol? And the reason is because it's being subtracted by 4. So my goal is to cancel all the numbers around the x. So if you're subtracting by 4, the inverse operation here is add 4 to both sides. And if I do that, I can simplify, and I'll get that negative 10 plus 4 is negative 6. You know, same sign, add, different sign, subtract. Keep this side of the higher number, then you'll be exact, y'all. So this is negative. The inequality symbols are greater than or equal to. So it's just greater than or equal to, bring it down. And then you bring down the x, and negative 4 plus 4 is 0. Notice that I always read this to make sure that they cancel, and I didn't make a mistake with my sign. Now I have as an answer that negative 6 is greater than or equal to x, and I need to graph this. But here's the deal. We talked about this before, and I just want to do a refresher, that this symbol on the top, when it says x is less than 5, could be used or be seen as the arrow of the head of the arrow. So that's like pointing that way, not the number that's eating, but this pointy side, right? This is the open side and the pointy side. That's pointing to the left, and this is pointing to the left. So that's pointing to the same side. You just go to the left. Here, this is pointing to the right, but you can't just draw it to the right. Only follow arrow when variable is first. So before you graph these, you have to make sure that the variable is always first. In this case, the number is first when you read it from left to right. So I rewrote this over here. And what I'm going to do is that I'm going to write the variable first. The way I do that is that I'm going to switch it around, right? So I'm going to take this x and move it to the front. So this is going to be x. I'm going to take this -6 and move it to the end. So this is going to be -6. And now, very, very important, I cannot change the meaning. So as you can see, Pac-Man, if you will, or the alligator is eating the -6 and is pointing to the x. So when I rewrite this, I have to make sure that Pac-Man's still eating the -6 and the pointy side is going to the x, so that this statement still holds true and I don't change its meaning. Now the variable is first. Now it's way easier to graph it. X is less than or equal to -6. So I go to my number line. I always plot 0 first. Then I put one more tick mark and I go to -6 and I mark it there. Okay, and then now I'm going to have a closed circle because remember, the equal to symbol at the bottom fills in the circle. This little line at the bottom will fill in the circle. And then do we go to the left or to the right? Where are we shading this? Well, we're shading to the left because that's where the numbers that are less than or equal to -6 are. And if you're not 100% sure, just follow the head of the arrow. It's pointing to the left. So we're going to graph it to the left. So this is how we graph these. Not that bad. All right, let's go to what happens when we're multiplying or dividing by a negative number. So adding and subtracting was very, very similar to adding and subtracting equations. But how do we solve this when you are multiplying? So let's look at the first example. -2x is less than 6. Check it out. Why it's x not by itself? Well, x is not by itself because this is being multiplied by -2. So we need to divide by -2 on both sides in order to get the x by itself. So when I do this, -2 divided by -2 is 1. So that's canceled. So I'm bring down the x, but look what happens. When multiplying or divided by a negative number, flip that sign. Did I just divide by a negative number? Yes, I did. I divided by the -2 on the left and -2 on the right. And remember, you always divide by the number with the variable. Because I divided by a negative number, I need to flip this inequality symbol. So this inequality sign needs to be flipped. Before it was less than, now it's greater than. And then you divide normally. 6 divided by -2 is just -3. This will be my answer. And if I'm going to graph this, okay, if I'm going to graph this, then you know how it goes. Number line, plug in the 0, plug in the -3. And then it's going to be an open circle. And am I going to the left or to the right? Well, where are the numbers that are greater than -3? They're to the right-hand side. Where is this arrow pointing? To the right-hand side. So you have two different ways to know if I'm shading to the left or to the right. Now look at the problem on the right-hand side. Very similar, but this time the 6 is negative. So 2x is less than -6. How can I get the x by itself? Well, I'm going to have to divide by 2. And if I divide by 2 on both sides, the 2's cancel here, the x comes down. But the question is, did I divide by a negative number? And the truth is, I did not. I divided by a positive number. I divided by +2 and by +2. Yes, 6 is negative, but that's not the number I'm dividing by. Okay, so because I did not divide by a negative number, this time I do not flip the symbol. I leave it alone. And then I divide -6 by 2 is -3. And hopefully you can see that that's the answer. Okay, it was only one step. That's the answer. And when I graph this, it's going to look similar, but not exactly the same because now, okay, I'm going to go to 3, -3, I'm still -3, but now I'm going to go to the left because I care about the numbers that are less than -3 this time. So this example is right here, so you can see the difference between when to flip the sign, the inequality sign, and when not to flip it. You only flip it when you're multiplying or dividing by a negative number. All right, perfect. So let's check it out because now we're going to solve some problems that require multi-steps. So example 1, here we go. Example 1 says 3x minus 4, it's greater than 8. So why is x not by itself? X is not by itself because it's being multiplied by 3 and subtracted by 4 on this side of the inequality symbol. So I'm going to draw my line down to make sure that I'm going to cancel on the numbers on the left-hand side, 3 and -4. Now, you imagine that this is an equal sign, and you're going to treat it the same. Which number do I cancel first, 3 or -4? Well, I'm going to cancel -4 because it's the number that does not have a variable. So I'm going to add 4 to both sides. So plus 4, what I do on one side, I have to do it on the other. -4 plus 4 goes to 0, which is perfect. So I just bring down 3x. I bring down the inequality symbol just the way it is. And 8 plus 4 is 12. Why is x still not by itself on that side of the inequality symbol? Well, because it's being multiplied by 3. So the inverse operation is divide by 3. And when you're doing one side, you're going to do it on the other. This cancels. And the answer is x. Question, do I have to flip this sign? And the answer is no, because I did not divide by a negative number. I divided by a positive number. And 12 divided by 3 is 4. X is greater than 4, so I was able to solve for x. This is very simple to graph. Okay, hopefully you're able to graph it. Before I do, I put the 0 in the middle. I also put a tick mark to mark 4. I open circle because that's just greater than, and that says x is greater than. Where are the numbers that are greater than 4 in the number line? Well, they're to the right of 4, all right? 5, 6, 7, 10, 100, 1,000. They're to the right of 4. So all these numbers are solutions to this inequality, and that is the answer. Let's do example 2. What happens with example 2? So example 2 says 5 is minus 10x is greater than or equal to -25. So again, I want to get x by itself. So I'm going to divide this into 2 parts to make sure that I cancel everything around the x. And I'm always going to cancel the number without the variable first, 5. Well, this 5 is positive. So what is the inverse of positive 5? -5. And what I do on one side of the inequality symbol, I better do it on the other side of the inequality symbol. So let's simplify. 5 minus 5 goes to 0. And you drop down the -10x, drop down the inequality symbol, so greater than or equal to, and then -25 minus 5 is -30. Awesome, we're almost done. X is not by itself because it's being multiplied by -10. Remember, we treat this just like equations. So what's the inverse operation? Divide both sides by -10. What I do on one side, you gotta do it on the other. So when I divide by 10, I just have x left, and always a question, do I flip the sign? And this time the answer is yes. You absolutely need to flip the sign. All right, you gotta flip it because negative. All right, you're divided by a negative number. You should take negative people out of your life. They divide, so take them out of your life. My goodness, just walk the other way. All right, so x is less than or equal to a -30 divided by -10. That is +3. Because we don't like negative people, we stay positive. So x is less than or equal to -3. And of course, we need to graph this in the number line. So here's my number line, always with 0, and then 3, +3 is to the right of 0. I always write 0 for reference. This is going to be an open circle. Actually, it's going to be a closed circle because you have the equal to symbol at the bottom. So that equal to symbol, that line fills in that circle, and then it's less than. So where are the numbers that are less than 3? To the left of 3 on the number line. And that is how you graph this problem. I have one last example, And that will be the last example. What happens if you have variables on both sides? Well, again, you're going to treat this just like if it was an equation. So because you have parentheses, the first thing that we're going to do is distribute those parentheses. So 4 times 3x is going to give us 12x. There's a plus sign, so plus. 4 times 2 gives you 8. And then you bring everything else down. Try to keep the symbols aligned. So less than or equal to 10x plus 6. And then I'm going to move all the variables to the left this time. So again, this is my left and this is my right. So I'm going to draw this line. And I'm going to move all the variables to the left. So if there have any variables on the right, I'm going to cancel them using inverse operations. So minus 10x minus 10x. And then I rewrite this. So 12x minus 10x, that just gives me 2x. Okay, 12 minus 10 is 2. Drop down the 8, drop down the inequality symbol. 10x minus 10x gives me 0. It canceled, which is the whole reason why I did that. And you bring down the 6. And hey, it's a two-step inequality. We know how to do this, just move, divide, move, divide. So now we're going to cancel the 8, subtract 8 from both sides. This cancels, and you get 2x. Bring down the inequality symbol is less than or equal to 6 minus 8, which is negative 2. And then the last step, get x by itself. X is not by itself on that side because it's being multiplied by this 2. So I'm going to divide by 2 on both sides. This cancels, and x. So do I flip the inequality symbol? Well, did I just divide by a negative number? No, I did not. So because I didn't, I'm going to leave that symbol alone. And then negative 2 divided by 2 is negative 1. So x is less than or equal to negative 1. And the last graph of the video, hopefully you're able to do it before I do it. So you should be a negative 1. This is going to be a closed circle because we have the equal to symbol at the bottom. So that line at the bottom fills in the circle. And then you go to the left. And that is how you solve linear or how you solve inequality and you graph it in a number line. If you need additional help, please don't hesitate to contact me. You can always shoot us an email. You can always check out our website to ask for additional and personalized help. This is Master Cruz with Virtual Math Masters, so you never do math alone again.